Hi, welcome back. In this video, we're going to talk about perpendicular distance. What do we mean by this? Well, so far in this unit, we've been talking about parallel lines and transversals. Alternate interior angles, alternate exterior angles. What we're really interested in now is if we have a set of parallel lines, can we find the distance between the lines? Notice how we cannot use this distance diagonally because diagonal distance does not give us a direct distance between the two. We want the distance that is perpendicular, that is directly across from the two lines. And that's the goal here for today. We're going to do an example or two, and feel free to pause it, take some notes, and let's begin. So here we have a scenario. We want to graph the following two equations. Then we want to find the distance between the lines. Notice how the first one is in standard form. We can't really graph anything in standard form. We want to make sure that we would convert this one to y equals mx plus b form. The second equation is already in y equals mx plus b form. So if this is in y equals mx plus b form, notice how the slope here is 1 and the y-intercept is -2. So m equals 1 over 1 and b equals -2. Since I have the slope and the y-intercept, I can go down to the y-intercept of -2 and then graph the slope of 1 over 1. And I can also go -1 over -1 to go in the other direction. And when I connect these, this is my equation y equals x minus 2. In order to graph the other equation that's up here, I need to convert it to slope-intercept form as well. To do that, I need to make sure that y is by itself. So I'm going to move the x to the other side. So I have -y equals -x minus 4. And then I can divide everything by a -1 to isolate the variable. So y equals positive x plus 4. From here, I can tell that my slope is also 1 and that the y-intercept is 4. So I can go to 4 and make the slope of up 1 over 1. Up 1 over 1 as well. Since the slope is the same, we can tell visually that these lines are parallel to each other. This is y equals x plus 4. Right? Now, what I'm interested in is finding the perpendicular distance between them, the distance that is diagonal from each other. I can't just go up and count 1, 2, 3, 4, 5, 6, because this distance would have been diagonal between the lines. I want the distance that's directly across from each other. And to do that, I need to figure out a line that's perpendicular to these two. In order to find something that is perpendicular, I have to look at the slopes. Currently, the slope is 1 over 1. If I want to find a perpendicular slope, I need to do the negative reciprocal. I flip the fraction, which doesn't really change, but then I change the sign. And then I pick any of the points on the line above. For example, this one. Let's say we have -1, 3. And I'm going to use the perpendicular slope, which means I'm going to go down 1 over 1. Down 1 over 1, down 1 over 1. This line is now going to be perpendicular. And to be honest, it doesn't really matter which points you use. You can use this one. You can go down 1 over 1, down 1 over 1, down 1 over 1. Since the lines are parallel, the distance between the lines should always be the same. Right? I can use this point, down 1 over 1, down 1 over 1, down 1 over 1. The distance for all these three lines that I drew should be identical. So how do we do this? How do we find the distance between the 2 points? Well, there's 2 routes. I have the distance formula, which I'm going to do over here. x2 minus x1 squared plus y2 minus y1 squared. And I can also, once I label this as x1 and y1 and x2 and y2, I can plug it into my formula to solve for the distance. At the same time, I can do a right triangle. Pythagorean theorem is also a way to find the distance on a graph. And for this one, we would do a squared plus b squared equals c squared. It doesn't really matter which method you prefer, right? You can do a right triangle or you can use the distance formula. So let's do the distance formula real quick. I'm going to plug things into my formula, which is x2 is 2 minus negative 1 plus y2, which is 0 minus 3. As I simplify the parentheses, subtracting a negative is a plus. So 2 plus 1 is 3. This turns into 3 squared plus negative 3 squared. When I square the values, they will both turn into positive, because negative times negative is a positive, and positive times a positive is a positive. And this gives me d equals the square root of 18, which comes out to a decimal, right? About 4 point something. Now, if you prefer to not worry about the negative numbers and subtracting negatives and things like that, just create a right triangle. You can do it here. You can do it here. Because we can always count the vertical distance and the horizontal distance to find the c value. And then I have 3 squared plus 3 squared equals c squared, which is 9 plus 9. And then when I combine them, to get rid of the c squared, I do the inverse, which is square rooting. And c would be the square root of 18. Notice how we get the same value, regardless of the method that you choose. So, as you go through these examples, pick the method that you prefer. If you know your tendencies and you're more likely to make mistakes here with like subtracting a negative, right? If you're someone who tends to do careless mistakes here with subtracting negatives or squaring negatives, then stick to Pythagorean theorem where you can just focus on a positive distance. All right. Let's try another example. For this one, I want to graph the line y minus 3 equals 2/3 x plus 2, which is currently in point slope form. Now, I don't have to convert this to slope-intercept form. What I can do is I can compare this to the original form. From here, I can actually already locate the slope, right? I can also locate the point that we're starting off of. I'm not going to start at the y-intercept, but I can identify the x value and the y value. Now, the original equation is minus x1, so notice how we have a plus 2. That means we're going to change the sign to negative 2. And then with 3, we have a minus 3, so the value that we plugged in here was a positive 3. When we're identifying the point, we're going to want to use the opposite of this value and the opposite of this value to start my starting point. So I go now to the graph and I plot negative 2, 3, which is here. From here, I can use the slope of 2 over 3 to graph it. Up 2 over 3. Down 2 over 3. I always recommend graphing at least 3 or 4 points in order for the line to be pretty accurate. Now, I want to figure out the distance between this line and the origin, which is down here. I want to figure out this length. Now, I'm going to construct another line that's parallel that goes through the origin. So I'm going to use the same slope. Up 2 over 3. Up 2 over 3. Down 2 over 3. Down 2 over 3. It helps me personally see 2 lines so that I can figure out which points I want to use. When I see the 2 lines, I can find the distance a little easier. Now, the slope was 2 over 3. The perpendicular slope should be the negative reciprocal of the slope. We're going to flip the fraction and change the sign. So I pick a point and go down 1, 2, 3 over 2. And this is the distance that I care about. I can use these two, down 3 over 2, down 3 over 2. It doesn't matter which point you use, as long as the slope here is always the perpendicular slope. And hopefully you can see why the symbol here is perpendicular. It's perpendicular because perpendicular means two lines intersect at 90 degrees, and it forms a nice right angle. That's why we use this notation for perpendicular slope. Now, to find the distance, again, there's two methods. Pick whichever method you feel more comfortable with. I can use this point and call it negative 2, 3, and this point of 0, 0. I can do a right triangle, count the squares, and I can say 3 squared plus 2 squared equals c squared. 3 squared is 9, 2 squared is 4, and when I combine like terms, I get 13. So as I square root both sides, I get the square root of 13, which is a little bit more than 3 as a decimal. I can easily do this as well using the distance formula, x1, y1, x2, y2. I'm going to do the distance formula down here, which is really just the square root of x2 minus x1 squared plus y2 minus y1 squared. When I plug in the values, I get 0 minus negative 2 plus 0 minus 3. Subtracting a negative should change this to a plus, so the distance turns into 2 squared plus negative 3 squared. When I square both values, they both turn into positive, which is 4 plus 9, which comes down to the same thing, right? The square root of 13. No matter which method I use, if I do it correctly, I should be able to get the same thing. Okay? Well, this wraps it up. Feel free to like the button, subscribe if you haven't already, and as always, we'll calculate later.